right, continuing with our exponents. So today our goal is I can write and simplify rational exponents in more than one way. So what the difference here is we're talking about rational exponents. So it's section 3.3 part 2. And first of all, let's talk about defining rational exponents. Now, first of all, exponents can be applied to rational exponents. Okay, in other words, fractions, exponents. However, it means something quite different in the sense of repeated multiplication. Okay, so for instance, given n and m, which are in the set of integers, and x is a real number. Okay, so you maybe remember in the set of or as an element of, and in this case, integers. Now, some textbooks will use the letter Z for integers. They both mean the same thing. Okay, so we have integers. We know that, first of all, what happens if I have x to the power of 1n? Okay, so 1 over n. So what that means is it's the nth root of x. So we pronounce it nth root of x. Okay, so when I'm looking at x, in other words, any number to the power of 1/2, what that means is I'm talking about the square root of x. Now, you're saying to me, hey, hold on, that's not the square root of x. Now, if anyone ever watches me when I'm doing calculator work, I often put, and when I'm finding the square root, I often put it to the power of 0.5 because I find it easier than finding the square root button. Okay, so often, so this is what happens. We're talking about the square root of x. Now, square root, because it's so common, what happens is we often don't put the little number 2 there, okay, because it is a common operation. So if you don't see a number between the hook of this root sign, then it means square root. Now notice what they've done. They've taken the denominator and put it in the crook. So I think that's the fancy word for it. Crook of the root sign. So let's see what happens then if we have another one. So if we have x to the power of 1/3, what I would do is that would be x, and I would put my little number 3 here. And what that means, or how I pronounce it, is it would be the cubed root. Okay, and some calculators have the cubed root button for them. However, it's possible that you could have the 4th root or the 5th root of a number. So let's actually take a look to see what's happening to these numbers when it's in this type of form. Okay, so the first one is 4 to the power of 1/2. So that is the square root of 4. And you know what that is because you've dealt with square roots. But if I actually rewrite it in this form, this new form, so I put the little 2 here in the 4, what that would mean is I need 2 items that are identical that multiply to get us the 4. Okay, so it's something like when we simplified rational expressions before, radicals, and we did that in one of our previous units. So what's happening here is you know that 4 is the same as 2 times 2. And because of that, when I take the square root of it, there's 2 of them, out comes of the root sign 1, 2. Okay, so that's what happens. And I'm just going to move this down a little bit. Okay, so what that equals then is 2. And for some reason, my pen likes to go where it wants to go. Now, when we look at 8 to the 1/2, you know that we've done this before as well. And what that means is we would go, as soon as my pen likes to write on that side, which it does not like to today, equals the square root of 8. And you know that that's the same as 2 times 2 times 2. So I need two identical things in order for it to come out. And you can see the two identical things I have here is 1, 2. So I have two 2's. So those are going to come out. But if you notice, I have nothing to match with this last 2, the third 2. So it has to stay there. Okay, so the last 2 has to stay underneath the root sign. And if we keep on going, now let's look at 8 to the power of 1/3. So the third root or the cubed root. So again, what I can do is I can put the 3 here, and that would be 2 times 2 times 2. So the same as the previous question. But the difference being here is this 3 here tells me I need 3 identical things to come out. So I have 1, 2, 3, and I have nothing else left here. So there's nothing going to be underneath the new root sign. So that is answer of 2. In fact, 8 is a perfect cubed root. Okay, so just like 4 is a perfect square root, 8 is a perfect cubed root. Okay, so let's look at 16 to the 1/2, okay, which is, if I write it this way, the 2 here, 16, and we know 16's the same as 4 times 4, and there are two identical 4's and nothing left over, so there's nothing going to be nothing underneath the square root. So my final answer then for here is going to be a 4 with no root sign. Okay, and here's another one. So 16 to the 1/4 this time. So I'm looking at the fourth root. So again, what I do here is I can write it in this root notation. And what that would be, it would be the square, the fourth root. So I have to put the little 4 here of 16. Okay, now remember that 4 can't be located here. Can't be located there. The reason being that would be 4 times the fourth root of 16. Okay, so just be really careful. It's a little tiny 4. And so it means I would need 4 things that are identical to come out, if that's possible. Well, 16 we know is 4 times 4. Okay, and obviously that doesn't have 4 things that are identical. It's only 2 things. So, and for some reason, let's just do that up. Maybe that'll help. So when we go back up here again, what we can do is we can then change our 4's, each one of our 4's, to a 2 times 2. So 2 times 2 times 2 times 2. So now you can see I have 4 identical items. 1, 2, 3, 4. And according to this, I need 4 of them in order for it to come out. So my final answer is going to be 2. So actually 16 is a perfect fourth root. All right, so now let's take a look to see some other stuff. Okay, so defining rational exponents continued. Okay, so we're still defining them. So in general, what happens if I have a base to the power of a rational exponent, notice this time my numerator isn't a 1, it's an integer, so m over n. What that means, again, the denominator is in the crook of the root sign, and my m can be put in a couple different places. It can be put in either I take the nth root of everything and take that answer and then to the power of m, or I can put the m inside the root sign, do that first, and then take the nth root. Either way will give you the answer. Now, which one are you going to use? Well, it's going to depend on your base number, whether it's easier to work with or not. So let's look at some examples again. So we have 4 to the power of 3/2. Okay, so 4 to the power of 3/2. So first of all, I'm going to write it in my root. And to be honest with you, I find usually this way works usually most of the time. Okay, so I'm going to take the square root of 4 and then I'm going to cube it. The reason I say this works better sometimes, otherwise if I put the 3 in with the 4, so I have 4 to the power of 3, that's a pretty large number because that would be 16 times 4. So again, that's creating a larger number and usually that's harder to work with. So what I can do is now I can take the square root of 4, which I know is 2, and then I can do 2 cubed, which is 8. Okay, so let's go to this next one over here. So again, I'm going to take the cubed root, put my little number 3 here, cubed root of 27, and then I'm going to square that answer. So the cubed root of 27 is 3, because 3 times 3 times 3 is 27, and then I have 3 squared, which is 9. And then if we look at the next one, I have 5 quarters to the ninth. Now watch what happens with this one. So if I do it the same way, I would have the fourth root of 9, all of that to the fifth. Now my problem with the fourth root of 9 is it's not a perfect fourth root because the only way that I can write a 9 is 3 times 3. Okay, it's a perfect square, but not a perfect fourth root. So it doesn't work in that form for that way. So that means then for this one, I'm going to try and do it the other way. So I'm going to switch to a different color just so that you can see the difference. So this time what's going to happen is I'm going to write it as the fourth root of 9 to the power of 5. Now the reason I'm doing that, because now you're going to see that's the same as 9 multiplied 5 times. 2, 3, 4, 5. And according to this, I need 4 identical items. So I have 1, 2, 3, 4. So those are going to come out as 1, 9. And this, I will have 1, 9 left underneath the fourth root sign. So it becomes 9, the fourth root of 9. Okay, so that's one instance where this way works better than the other way. Okay, now let's go and do another one. Let's switch colors that make it a little bit more bright for you. Okay, so this time I'm finding the fifth root of negative 32, and then I'm going to square it. Okay, now watch right now I have a negative 32. So that's the same as going negative 2 times negative 2. Ooh, I forgot my little 5 here. Better remember it. Times negative 2. And I think I can do it 5 times. I hope so. 3, 4, 5. And if you actually multiply all those together, you would find I would end up with a negative 32. Okay, so this is a perfect one. Out will come negative 2. And it's all of that is squared, so my final answer is 4. Now you're saying, does my calculator not have these buttons? It maybe does. However, you're not going to get any marks from me if you just type it in and out comes your answer. All right, now I'm just going to soon run out of time, so I'm going to stop the video and we'll complete these last 2 examples.